Hello everyone, my name is Longxu. Today I will present my work in AAAI. It's named MultSpider towards benchmarking multilingual tactical semantic parsing, and this work is done during my internship of Microsoft Research Asia. And in this work, we present a new benchmark named MultSpider. Is the largest tactical multilingual dataset. It has 7 languages, and based on this benchmark, we conduct a detailed analysis and extensive experiments to identify the specific lexical challenge and structural challenge brought by MultSpider. And moreover, we propose a new data augmentation method named SVAE. It's a new data augmentation method from the perspective of schema. So let's begin with the MultSpider benchmark. We built this on the top of challenge multi-table cross-database English spider dataset, and is the largest one with high quality. It has 7 mainstream languages as shown in the left. We translate both question and schema. And during the construction of benchmark, to ensure the dataset's quality, we identify 5 typical translation mistakes as shown in the left finger, and based on that, we organize our construction pipeline, consist of multi-rounds translation and validation. We conduct analysis on MultSpider dataset. We can find it's more challenging. As shown in this figure, the specific language properties like hiragana and katakana in Japanese, and the morphological rich language like German or French. And it also contains something like dialects and long saying that require further common sense reasoning of the downstream parser. Okay, another contribution of our work is schema augmentation framework. It consists of 2 steps. The first one is back translation. We employ the off-the-shelf machine translation tools like Google MT or Facebook M100 model to translate the column into a set of synonym candidates. Moreover, we employ the natural language inference model to do schema verification, and this is designed to ensure the quality of the augmented schema elements. We have done a lot of experiments on this data set. The first one is zero-shot sighting. That means we don't have any human labeled training data, and we directly use the English training data and test it with the target language. For example, we have set 3 sightings in this paper. The first one is directly predict. That means we train our model on English and test it in target. And another one is translate and predict. That means we train our parser in English, but we test our parser in before you test our parser, we first translate our sentence from text language into English language. And the last one is translate then train. We first train our parser in English, translate our dataset from English to target, and train our model on target language and test it in language. And we can see that better model enables better zero-shot transfer. For example, Robota exists multilingual bird a lot of. And we can also see that compared with translate and predict, the directly predict get a better performance, about 2%. And we suppose this because machine translation creates more mistakes in this sighting. And another important finding is that strong pre-trained language model with strong machine translation system, we can get a promising zero-shot performance, as shown in this line, because English can only get 70% accuracy, but without human-labeled dataset, in this non-English dataset, we can also get about 60 accuracy. This is really amazing. And another experiment is about monolingual and multilingual. And we can observe that the performance of Japanese is significantly behind other language, because as I said before, the Japanese has more language properties. And another finding is that in non-English languages, this six languages, they are left behind the English language about 60%. And the same is significantly improved the non-English languages about 1%, about 2%. And we have also done some discussion about this. The first one is what caused the performance drop in non-English languages. As we can see from here, the specific language properties and dialect theme lead to the performance drop in non-English languages. And another one is we can find that schema linking becomes more challenging for non-English language. As you can see here, the lower the score be and the challenge of schema linking process. And another interesting question is how schema augmentation algorithm improves the model. We have done a quantitative analysis about the augmented schema elements. This can be categorized into two classes. The first one is synonym. As we can see here, that means the semantically identical with the original schema, but with different lemmas. And another one is morphological variance that changes the forms of schema syntactically. So to calculate the future work includes we can develop a multilingual statistical system and apply in the real globalization scenario. And another one is leveraging better pre-trained model and advancing architecture design to address the lexical challenge and structural challenge in multilingual settings. And the last one is to expand our schema augmentation algorithm to more table-related tasks like table fact is the dataset for table-based fact verification, and we can further improve the schema verification accuracy. That's all. Thank you.